Today we're going to talk about lines and angles, section 3.1. So we're talking about lines and angles contained on geometry here. Talking about some more of the kind of vocabulary concepts of geometry, more or less, really. So lines and angles, section 3.1. Some of the vocab we're going to talk about today. First one is parallel lines. Parallel lines are lines in the same plane that do not intersect. So they are lines in the same plane that do not intersect. Can anybody give me a real-life example of parallel lines? Railroad tracks are a perfect example of parallel lines. Okay, yeah, the railroad tracks are not going to intersect. Why? Well, that's probably bad news for that train. All right, so parallel lines, lines in the same plane that do not intersect. Perpendicular lines, lines that intersect at 90-degree angles. So they are lines that intersect at 90-degree angles. Something like that is perpendicular lines. Where in real life do we see perpendicular lines? Streets, intersections, right? Most intersections are perpendicular lines. Now, not all intersections, but a lot of intersections meet at a perpendicular line. If you think about it, right out here, right by 3M, that four-way stop. Those would be an example of perpendicular lines right there. Okay? Skew lines. Skew lines are lines that are not coplanar. So let's go back to vocab terms here. What's it mean to be coplanar, first off? Who remembers what coplanar means? Same plane. So coplanar was same plane. So if they're not coplanar, what's that mean? Not in the same plane. Okay? Now it's kind of hard to draw in a two-dimensional set here. So I'm going to use some rulers here. Alright, so yeah, great example. An overpass example of skew lines. Parallel planes. Planes that do not intersect. Okay, so now we're talking about planes that do not intersect. Where in this room is an example of parallel planes? The ceiling and the floor. Yeah, ceiling and the floor would be an example of parallel planes. It's a great example. And then we have a transversal. Transversal is a line that intersects two coplanar lines at two different points. So let's say if I have a line, two lines there, that black line, that'd be my transversal. Okay, so the transversal is just a line that intersects two lines at two different points. All right, so just a line that intersects some other lines. Transversal. Next, we're going to talk about corresponding angles. Corresponding angles for two lines intersected by a transversal. Corresponding angles are a pair of angles that lie on the same side of the transversal on the same sides of the other two lines. Now, if you look up, Quinn, if you point straight ahead, Quinn, do me a favor. Point straight ahead, and then raise your arm way up high. Does everybody see that poster way up top there? No, there you go.
Oh, yeah.
There's an example of corresponding angles. Okay, so there's the poster dealing with corresponding angles. Corresponding angles are what I call same position. We'll talk about that here. Okay, corresponding angles are angles that would be in what I call the same position. Okay, and we'll talk about that further later. But corresponding angles are angles that are in the same position. Alternate interior angles. First off, let's talk about it. What's the word alternate mean? What's like a synonym? What's another word for the word alternate? Anybody? Where's it? Different. Yeah. When you think of alternate, I think of different. When you think of interior, what do you think of? Inside. Alternate interior angles are different inside angles. Okay? Alternate interior angles are different inside angles. Alright? So again, different inside angles. Alternate exterior angles. Well, what's alternate mean again? Different. Exterior means outside. So I would say they are different outside angles. And lastly, we have same side interior. Well, that one's pretty self-explanatory. Same side is same side, right? So same side interior angles is a pair of angles that lie on the same side of the transversal in between the two lines. Okay, that one again is pretty self-explanatory. So again, here's some of the examples we're going to talk about today. We're going to have to identify some parallel symbols or some parallel lines. Notice to denote something's parallel, we kind of use like parallel lines. A lot of times they kind of use them at an angle too. Okay, that's an example of parallel lines. Perpendicular is like an upside down T. Okay, so to denote something's perpendicular, you just write an upside down T. And then skew, lines that do not lie in the same plane and do not intersect. All right, we'll talk about those. So let's look at number one here. I want an example of parallel lines. I have 3 lines. I have H, I have G, and I have J. So I have 3 lines here. Which ones give me a pair of parallel lines? Trent, which one gives me a pair of parallel lines? What? Yep, so G is parallel to H. I'd write that as. Okay, and again, I'm going to use the parallel symbol to denote that they are parallel. A pair of skew lines. Which ones would be skew, Anderson?
What's that? J and H?
Yep. So J and H are skew. Now again, no special symbol for skew. And then which ones would be a pair of perpendicular, McCoolidge? Perpendicular? Which ones? Not H. H and G would be parallel, right? So which one then? Perpendicular means they're going to meet at a right angle.
Oh, so G and J.
Yep, so G is perpendicular to J. Alright, now does everybody see these symbols right here? What do you suppose those symbols mean? Anyone want to take a guess? What were H and J? Or H and G?
Parallel.
So what do you suppose those symbols mean? Yeah, those are parallel symbols. Okay? So to denote that 2 lines are parallel, a lot of times they'll put the arrow that way. That means they're going the same direction at the same space. Now we all know what the right angle means. What's the right angle mean here? Or the little box? Right angle or perpendicular. Alright? Take a couple seconds to try these 6 on your own. Now some of them do have multiple answers, but try identifying some parallel, perpendicular, and skew segments on your own. Alright, let's look at these here. So number 4, a segment that is parallel to DG. So notice, here's DG. I want a segment that is parallel to DG. Clark, what would you say? EH would be an acceptable answer. Now again, make sure you put the segment line above it. What's another acceptable answer you could say here? Anderson?
FJ.
FJ. Very good. Again, make sure you put the segment symbol above. 5. I want a segment that is perpendicular to GH. So here's GH. Which one would be perpendicular to GH? Read. JH. Is there another one that would be perpendicular? Which other one, Jeremiah? Yeah, EH is perpendicular as well. Next, I want a segment that is skewed to JF. There are 2 of them that are skewed to JF. Which 2 would be skew to JF? Oh, give me one of them. Claire. GH would be skew. What's the other one that would be skew, Simeon? That's the one you picked? Okay, so here's GH. Can you find another one? DE would also be skew. Nice job. Alright. Next, I want 1 pair of parallel planes. So now I want the whole parallel plane. Oh, give me a parallel plane, Blake.
Like the whole plane?
Yeah, like the whole plane.
Well, they don't have names.
They don't have names. So remember, if I don't count names, I just name with 3 letters. It's like what are the letters of the plane?
So, E, F, G, or J.
Not EFJ. Reed, want to help me out? You can name 3 coordinates. There's only 2 sets of parallel planes here. There's only 2 of them. There's only 2 that are parallel. Becca? Yeah, DEF and GHJ. So I'm taking this flat surface here and this flat surface there. Those are my parallel planes. Okay? Yeah, there's only 2 of them that are parallel planes. Next one, 1 pair of perpendicular segments not including GH. So I want something that is not GH and something that's perpendicular. Callie, what would that be? DE and EF. Sorry, DE is perpendicular to EF. Nice job. And 9, one pair of skew segments not including JF. So something that's skew and is not JF. Oh, what would you say, Colton? DE and which one? DE and HE? DE and HE would actually be intersecting. They actually form perpendicular lines. See how they're intersecting there? So I want something that's not intersecting, but it's also not parallel. Very good. DE and HJ. Notice those are not intersecting, but they're also not parallel. Right? Those would be skew. Last thing we're going to talk about today is the different 4 angle types here. So corresponding alternate interior, alternate exterior, and same side interior. Recognize my example up here. Okay? I have numbers 1, 2, 3, 4, 5, 6, 7, 8. Corresponding angles. We're in the same position. Now when I talk about position, I'm talking about if I were thinking this in a quadrant. We know quadrants, right? The coordinate plane. So everybody remember coordinate plane? I have quadrants 1, 2, 3, 4. Corresponding means they would be in the same position of the quadrant. So for example here at angles 4 and angles 8, those would both be like in quadrant 4 if you were to think of those as quadrants. Okay, if I go back up to here, what's another example of corresponding angles? 3, nope, not 3 and 5. 3 and 7. Yeah, 3 and 7 could be considered like the bottom left or quadrant 3. What's another example of corresponding angles? 2 and what? 2 and 6 would be corresponding. And then 1 and 5 would be corresponding as well. Okay? Alternate interior angles. Recognize alternate interior angles. Different inside angles. So I have 4 and 5 there. If I go back to my example up top, what's another example of alternate interior angles? 3 and 6. Yep. Those are on different inside angles. Alternate exterior. Again, recognize different outside angles. Besides 2 and 7, what's another example of alternate exterior angles? 1 and 8. And lastly, same side interior. Something that are both on the same side of the line on the inside. What's another example besides 4 and 6? 3 and 5 are all same side interior angles. So let's look at this here. Use the figure for exercise 1013. Give an example of each type of angle pair. Corresponding angles. I want to give some examples of corresponding angles. Quinn, can you give me an example of a set of corresponding angles? Yep. 2 and 4 would be corresponding angles. Nice job. Those are both being in the same position. What's another example of corresponding angles, Parker? So we had 2 and 4. What's another example of corresponding angles? 3 and 1. Nice job. Yep, those would be corresponding angles. Heston, another example of corresponding angles? 6 and 8. And the last set of corresponding angles, Audrey? 5 and 7. Good work. Now we have alternate exterior angles. Ty, refresh my memory. What does alternate mean again? Opposite or different. What's exterior mean? Outside. So can you give me an example of alternate exterior angles here? 5 and what? 5 and 4 are an example of alternate exterior angles. Nice job. Again, think about it this way. The inside would be in between your lines, so it has to be on the outside. So yeah, 5 and 4, outside the lines, exterior angles, or alternate exterior angles. What's another example of alternate exterior angles, Spence? 1 and 8. Nice job. Next, I have same side interior angles. Beast, which ones would be same side interior angles? Ooh. 2 and 6 are not on the same side of the line. 2 and 3, are those on the same side? Yep. So I'd say 2 and 3. What's another example of same side interior, Claire? 6 and 7. And last one of alternate interior angles, Coolidge, give me an example of alternate interior. 6 and 3. And another example of alternate interior, Anderson?
2 and 7.
2 and 7. All right. We'll be talking about these types of angles a lot this year. So you want to make sure you have these 4 down. And there's your assignment.